how we roll, man. Some rock, some win, some 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 win, man.
Hello everyone, and there is something going on with my OBS. That's interesting. Let me diagnose this very quickly. That's an interesting start of the show. Holy shit. Where is my webcam? Here is my webcam. Okay, hello everyone, and welcome to Showtime. So my name is Loris Crow, and we are executing a Showtime. Zig SHOWTIME is a show and a community for makers. Watch the show to learn about interesting projects, and join the Discord server to share what you're working on and to collaborate with other members of the community. And if that's not your style or you're new to Zig, make sure to check one of the other Zig communities to find one that suits you best. So hello, welcome to episode number 24. Today we are not going to have a interview for the joy of people that don't want 3-hour-long videos, but we're back to our roots with talks from speakers that are doing cool stuff with Zig. Before we get into the talks, I only have, I think, one thing to announce, like a piece of news to mention, and for that, actually, let me bring out a prop. Okay, so as you might know, if you have subscribed to the Zig SHOWTIME newsletter, because I mentioned it also in the newsletter, we are finally reaching the end of the pandemic. We're not there yet, but we're getting there, and people are starting to finally organize again in-person events. And the handmade community, more specifically Abner, who came on Showtime a few episodes ago, is organizing Handmade Seattle, which is a conference that's going to be in Seattle dedicated to software that is written, following the handmade philosophy. And what's nice about this is that it's an in-person event, but it's he describes it as a hybrid conference, meaning that there's going to be online chat servers. Questions to speaker are only going to go through this digital system, so that people that are in the room and people that are somewhere else, watching a stream online, can also be they're all equals when it comes to asking questions to speakers. That's, I guess, at least part of the idea. I'm bringing this up because the early bird ticket sale has started, and I got a ticket, and I was thinking that if everything goes well, I might actually go there. I think it would be interesting. And the idea is, if I go there, why not try to cause some chaos, upset some people, and maybe make something interesting to watch for the people that watch me on Showtime and watch the YouTube channel and everything else. And for that purpose, I got this. I have a interviewer microphone. I bought it used from Amazon. It was a pretty good bargain. It's like half price, and it was really new in the box. And so the idea is to somebody's commenting. Andrew's commenting. It looks like a grenade. Yeah. So the idea is to go there and ask people questions and have interviews and stuff. And I don't know, we'll see. I have to think more about it, but it could be interesting. So this also means that if you happen to be there, maybe we'll be able to meet. So check it out. People in chat, please share a link to. Actually, Abner is here. Abner, then please. Share a link to your conference website so that people can press the buy button if they want to. Okay, that was the only piece of news. Let me put down the microphone. Let's start with the talks. So let me bring up the title for the first talk, and let's get into it. Okay, so Johnny is the author of Zig Up and possesses a rare quality in the open source world. He is willing to put up with the madness found in the Microsoft ecosystem, and thanks to this spirit, he was able to create bindings for the full Win32 API, a feat achieved by very few as of today. The talk is titled Showing Zig How to See Through Bill Gates' Windows. And Johnny, the stream is yours.
All right, great. So it's good to finally show my face in this community. Hi, I'm Johnny. You might see my name around Marler 8997. And today I'm here to talk to you about how we can allow Zig to see through Bill Gates' windows. So what do I mean by this? Well, I'm here to talk to you about how Zig is now able to access the full set of Windows bindings. And you may say, well, Zig can already access some of these bindings. I mean, we can access things like the file system, you can do networking, threads, processes. And these things are important to have in the standard library, especially for something like Zig. Zig provides a very nice platform abstraction layer. Christoph, 1 second. I'm getting like some audio feedback on my voice here.
That is not on the show. That's on your system for sure. If you want, I can hide
check
your
1
screen.
2. Yeah, maybe I had the stream open. I think that's what it was. Okay.
Okay.
All right.
Are you good?
Yeah, I think we're good.
Great.
So we've got the standard stuff in the standard library, which allows us to build this abstract platform layer. But Windows is so much more. It's got network protocol specific libraries, cryptography, encryption. It's got game APIs like DirectX and OpenGL, audio, video, globalization, machine learning, and the list goes on and on. It's absolutely massive. So Microsoft has all these sweet APIs, and how do we access those? Well, the official way is through the C and C++ SDK. And those familiar with Windows programming will recognize the windows.h header file amongst many others. But we don't want to write our applications in C and C++. We want to write them in Zig. But wait a second, what about C import? Couldn't Zig just import the Windows header files? Well, some people have tried this, and the problem is it depends on two imperfect tools. The first one is Clang's ability to parse the Windows header files. Microsoft uses some extensions and some specific features that Clang doesn't interpret the same way. And the second is Zig's Translate C feature, and that tool we'll probably be able to make it better, but it probably will never be perfect, especially with all the versions of C out there. But that's not even the main problem. The main problem with it is that C and C++ don't actually have enough information to feed Zig's more robust type system. C doesn't know about single object versus many object pointers, doesn't know about null termination. And even worse is a lot of the information about the API is actually encoded in preprocessor logic. So, okay. To be honest, most Windows applications that access these native APIs are usually in C++. And when you don't have other languages, when you have other languages that want to access these, how do they do it? They don't even have C import like Zig does. So let's look at an example. In fact, let's look at a language that Microsoft created, so C#. So C# uses the Microsoft .NET framework, which is a wrapper around the native Win32 APIs. But what if C# needs to access the native Windows APIs directly? Well, it's easy. You just manually write your own bindings for every function you need to call. Here's the function to create a message box, and you just copy this code and paste it into your program, and you're good to go, right? You also need to copy all the constants and all the types that you need to pass back and forth. So basically, Windows punted and said, it's up to you. You've got to support your own bindings. Now, C# is a Microsoft language, and you might be surprised that this was the approach they took. But C# kind of gets away with this because you hardly ever need to call the native Win32 APIs from C#. Most of Windows functionality is exposed through their very substantial .NET framework. But Zig isn't a managed language. It's a native language that runs on bare metal. So it can't use the .NET framework. So we need a way to access those APIs directly. So for the most part, most Windows programming is done in C and C++. And when it isn't, it's up to each language to maintain their own set of bindings. One example of this is Rust, where, like Zig, it maintains a subset of the APIs in its standard library, but it also has a popular community-maintained project with the full set of Windows APIs. These APIs are manually maintained, and they're quite large. And I'm not even sure that they cover the full set of the API, but it's pretty impressive for what they've been able to put together. But this isn't really what I want to do. But wait a second, manual bindings. So Zig already has manual bindings. And with a lot of effort, we could extend them to the full API. But there's some problems with that. Zig isn't afraid to make breaking changes. And spending my time fiddling with bindings as Zig continues to evolve isn't really my idea of fun. So I went looking for alternatives. I looked for projects that have already put in the work to expose these APIs and tried to find something that I could use to generate them automatically. So I found this one project, Windows SDK Data. Great. So somebody went through and put all this Win32 API information in JSON files. So it's perfect. And it was really big. It was 114 megabytes. So sure, it must have all the API in there. That's pretty big. So in October, I just got to work. So October in 2020, I created the Zig Win32 Gen project. So this takes the JSON files and generates the Zig bindings that we need to be able to call into Windows. So after about a week, though, I had started encountering issues. Things like big chunks of the API seemed to be missing. There was information that wasn't available, and there wasn't the extra information we needed in Zig, like the different kinds of pointers. And I tried to contact the author about some of them, and I created some GitHub issues, but I didn't get any response. And there also wasn't any documentation that explained how these JSON files were generated. So I couldn't go through and fix the tool that generated them. And it didn't seem like they were manually generated either. So it was a really good concept in theory, but this one didn't appear to work. And I found a couple other projects that did something similar, but none of them really seemed to be up to the mark or usable. So I really like this idea of one person doing the work to encode the Windows API into a parsable format that anyone can use. It seemed like the right way to go. So I reached out on Zig's IRC for a little bit of guidance, and of course the Lemon Man, always helpful. He chimes in and he says, you could probably do all this with a couple of lines of Perl. And of course Lemon Man's correct, but I would rather do anything than write a couple of lines of Perl. So I decided to move forward without Perl. So I'd created this new Windows API project. I think I wrote it in Python. And this project was, I was going to create these JSON files, but I was going to document how I did it. It was going to be anybody could go in and contribute to it. And what I ended up doing was I did a combination of automation and manual, and I came up with this new format I called C-ish. So the C-ish format, it looks like C, and the idea behind it was you would take the C code in the Windows header files and you would copy them manually, and then you would just add some tweaks to it. So some of the tweaks you might do is modify the pointer types to say, hey, this pointer is actually an array, not a single object. That's the information we need to be able to generate our Zig code. Then you could add information that would normally be in the preprocessor. So things like what platform that API runs on, or different variations of a struct based on the platform. So I got my two projects now. We've got our Windows API project that goes from C-ish to JSON, and then we've got the Zig Win32 Gen project that goes from JSON to Zig. So now I'm now able to add all these APIs with relatively low effort. I copy and paste, add some tweaks, and then I regenerate everything. And life's good. So this means I can make a small change. If something in the Zig's language changes, I can make a small change in this project and regenerate thousands, hundreds of thousands of lines of Zig bindings to conform to the new spec. So this was the big advantage of having all of this automated. Having the Zig side of it be malleable and the JSON side of it be automated to represent the static information that doesn't change often. So this is great. I'm happy with the solution. And this was around November, December of last year, so a few months ago. And but then something happened in January 2021. I think I was browsing Google News and I saw a couple of articles about this Win32 metadata project, making Win32 APIs more accessible to more languages, which sounded eerily familiar. And I realized at the 11th hour, when my new project was just starting to spread its wings, Microsoft decided to reveal that they've been working on the exact same thing for the past 6 months. According to the Git history, they started their project 3 months before mine. So unfortunately, I retired my Windows API project and moved on to the now Microsoft supported one. And Windows had been out for 30 years before this, and so I guess I'm lucky that they decided to release it right when I was releasing mine as well. But it's all well and good. So we've got this new Microsoft supported project. But with it comes a new challenge. They don't generate JSON files. They generate this format called Windows metadata files, or WinMD for short. So this is the same format that .NET assemblies are in, the binaries that C# code compiles into. And this file format's not trivial to parse. So I didn't want to dive deep in right away and write a Zig parser for these WinMD files. So I decided to take the C# library and start with that. I'm familiar with C#. I knew how to use the reflection library, so I started there. And it was funny because at this time, Martin, also known as Specs Guy, he had already started writing a Zig parser in WinMD. So the thought was, well, I'll take my project I have now and have it start generating Zig code, and then later on I could port it to Zig and use Martin's library. So perfect. So I got to the point where I was generating valid bindings again from the Microsoft project. But then I think after about a week, I had this thought that I couldn't ignore. And I thought to myself, well, every language out there is going to want to write their own binding generator in their own language. The one for Dart is going to want to write theirs in Dart, and the one for D is going to be in D, and the one for Rust is going to be in Rust. So wait a second, they're all going to have to write these WinMD parsers. And that's pretty annoying, but what if they didn't have to? So what if maybe one person did the work to convert the WinMD to another format that everyone can use, like, I don't know, JSON or something? So here was my idea. Let's start with the WinMD, and just like any other projection, Windows calls these tools that convert WinMD into a binding projections. So I'll just create a projection that goes to JSON. And then once I have that, I'll use Zig's standard library JSON parser to parse it and then generate Zig code. Perfect. So now we can write this without having to write a WinMD parser in Zig. So unfortunately, I didn't end up needing Martin's work after all. So another interesting thing is this matched my original design very closely. I can still leverage my Zig Win32 Gen project. And that project, the JSON won't be exactly the same, but it contains the same information. And with a little bit of work, I should be able to leverage it. So that's great as well. So we just take out our C-ish, we replace it with WinMD. And I knew I'd have to scrap a lot of the work that I did before, but this seemed like the right solution overall. And I've already since then been pretty happy with this decision. Having those JSON files has been great. I've been able to use grep to go through, and other tools to go through the API. On one instance, Zig had we had a question in Zig about which symbols from MinGW we should include in our static libraries that we link against. And so all I did was I looked at every single symbol in metadata, and then I compiled a list and then matched it against the ones from the definition files in MinGW. So now, thanks to this project, we now have a complete set of libraries to link against. When we're compiling with Zig code, you don't have to download any dependencies. So that's been a really nice benefit. So I called this new tool Win32JSON-Gen. We go from WinMD, generate our JSON, and then we can generate our Zig code. And this is the design that I use to this day. So that's a little bit of history about what went into this. I went through like enough pain and torment that I felt like I had to share this history with everyone else in the Zig community, so you could know the pain that I had to go through to get to this point. So okay, so it's demo time. Let's see how we actually use this project. Enough talking about the history. So I'm going to open Visual Studio Code here, and we're going to start with a blank slate. We've got nothing in this directory. I'm going to go ahead and clone the Zig Win32Gen project. This is the project that converts the JSON files to Zig. So if you ever want to work on the binding side of things, you don't have to muck with the C# program or the JSON side of it. You can just work with the Zig code completely. So let's go ahead and clone this. The organization's called Marler Soft. And we'll go ahead and clone that. And it's pretty small repo. It clones pretty quick. And we can see up here in our file explorer, maybe let's zoom in a little bit here, the files. And we can see here's the source files. Most of the heavy lifting is done in this gen Zig file. So it's only about 2,000 lines, parses the JSON and generates the bindings for us. So okay, let's build it. And I'm a big proponent of making things easier on the developer. So in all my projects, if you run Zig build, it will either work or tell you what you need to do in order to get it to work. So let's go ahead and run Zig build. And we get an error here. So it says repository deps win32json does not exist. Clone it with. So this is my ad hoc package manager until we get an official one in Zig. So I'm just going to copy this command, paste it here. It's going to clone the repository for me. So this is downloading all of the JSON files that are generated by the other project. And we can take a look at that. So we have this new folder here called deps. And inside of it, we've got a README, which tells you how they're generated. It's a JSON representation of the Windows metadata. And it's just this one directory of all these JSON files. So if you wanted to, a lot of the basic stuff is going to be in system services here. So if we go to the top of this, we can see, oh, here's what true is defined as. Here's what false is defined as. I'm actually happy that I tried to generate another JSON format myself, because I learned a few things along the way about how to make a good JSON. So this all follows a pattern, which makes it easy to parse. And eventually I'm going to write a schema for this, but I haven't done that at this point. So that's what these files look like. It contains constants, functions, and types. And those are the three basic things that will be inside of these files. And in a minute, you'll see how that corresponds to the bindings as well. So okay, we've got our JSON files now, and let's run Zig build again. See what happens. We get another error. The repository Zig Win32 does not exist. So this is like a convenient feature that I found. When I generate the bindings, what I do is I generate them inside of the resulting repository where they're going to live. So this is the final repository that most users will see is Zig Win32, and that's where the bindings are. So when you generate them, you clone the repository where they'll go, and then it just puts them in there. So let's go ahead and clone that one. What's really cool is like when you generate new bindings, you can just cd into the repository and run a git k, and you'll see all the changes that are made. So that's really nice. Okay, so now let's run Zig build for a third time. And now something's happening. So we've got on the side here, you can see the progress. We've got 201 files here, and we're on about 170 right here, and it's showing us how big each one is. And at the end here, it'll print a summary telling you how long it took to do everything. So it took about 15 seconds to generate. So okay, let's cd into our Zig Win32 repo and take a look at what we got here. So it generates the main file win32.zig. And let's go into our file explorer here and just take a look at that. Gives you a nice message saying, don't mess with this, it's auto-generated. And the Win32 metadata repo actually has subname spaces now. So it categorizes things, based on what you're trying to do. So AI for artificial intelligence or graphics or media storage, things like that. UI is another one. So if we go in, let's maybe look at an example here. Let's go into graphics. Let's go into UI color system. So here's what the bindings look like, and they're separated by these sections here. So the first section is always the constants section. So we can see here, okay, we have this GUID. We have some max color channels, constant, a bunch of values and flags and all that. And then in the next section, we have our types. So, the ever important CIE XYZ type, you've got that one. So this will contain structs mostly. But another interesting thing is it contains COM types. So even though this is the type section, we actually have functions here as well, because the COM interface is a hierarchical set of objects that have functions on them, just like you would with classes in C++. So luckily, I had prior experience with this because I had written COM bindings in the D language some number of years back. So I had already known how that they worked, and I was able to generate this Zig code that allows you to call into COM types. And a lot of really nice Windows functionality is hidden behind these COM interfaces. And I'll show you how we can call those in a few minutes. So we've got our COM types, and then here's the functions section. So one nice thing about this is you'll see we don't have a lot of big namespaces in our types. These functions look pretty much like they would in the Zig standard library. With HDC and RGB triple, and the way that that's able to work is we just import all of the symbols at the end after we're done generating. The other thing to note is all of these files are generated in a single pass. We don't have to do multiple passes, so that makes it quick. It takes 15 seconds instead of potentially taking minutes. In the next section, we get our Unicode aliases section. So this is a common programming technique that's used with these header files. There's usually a lot of times there's two versions of functions when they take a string usually, and one will take a ANSI encoded string, and one will take a Unicode UTF-6 or WTF-16 encoded string, which will end with W like this. So, but lots of programs don't type the A or the W. What they'll do is they'll define whether they want to use Unicode or ANSI, and then they'll just use the variant without the suffix at the end. So I allow you to do the same thing here, and the way that you do that is you define a public symbol in your root module called Unicode, and you set it to either ANSI or wide, and then you can call the non-suffixed versions of these functions. So if you don't have that Unicode symbol, you'll get a compile error. With a message telling you need to define that in your root module. So that's nice. It's really nice in Zig as well how it works, as opposed to the C and C++ version. It works a lot nicer. You could potentially define this differently for different modules if you like as well. So, and then the next section is the import section I was talking about before, which prevents you from having to type out the full names of everything. And because these were originally C and C++ headers, that's where these came from. The C and C has a global namespace, so you can't really have name conflicts, because if you did, then the C headers wouldn't work. So, and then here's the test script. So we can run the test. The test takes actually quite a while, even though there's no actual code in here. It won't actually run, but if it compile, it won't link. So it will compile, but it won't link. There's some library I'm missing the last time I tried it, but sometimes I've gotten it to link. So I'm gonna let that finish here. While that's running, let's look at some examples. Inside of the repository, I have about 4 examples in here that I use to test the bindings when I take a new update. Let's look at Hello World. So this is Hello World without using any of Zig's standard library, except for this one piece here. I use this to get the calling convention, but we don't actually use any code or structures or types from the standard library here. And you'll notice here this everything import here. So this everything module isn't in the metadata. It's something that I cooked up. And this is one of the advantages to having these bindings automatically generated. The everything module takes everything, every single symbol in the metadata, and just exposes it in one module. And this is what it looks like. So every single symbol is exposed and is just an import to where it appears in the metadata. And let's see how big it is. It's about 160,000 lines. So there's about 160,000 symbols in the Win32 API. So okay, it looks like our test is finished. So we know it compiled, and it didn't link, but that's okay. There's no code to run anyway. We don't need to link it. So let's go back to our examples and see if we can build them with our newly generated code. Zig build. And this code will look very similar to the C and C++ Windows programmers will be familiar with. You just call get standard handle. You can use constants. The using namespace features makes it feel a lot like it did in the old days. I'm not endorsing this method of writing Zig code. This is more for proof of concept to show how you can take your C and C++ code and port it to Zig and have it look very similar. So we build these examples. Let's go ahead and run Hello World just to make sure everything's going well. Perfect. Hello World. But let's look at something uses a little bit more of the API. This is Hello World window. So in this case, I opted not to use everything, but to use the specific modules that I needed. So there's a Zig module here that gives you some nice convenient functions. One of them is this L function, which is synonymous with the _L strings in C and C++. It just converts your U8 string into a UTF-16 string. So things like that, just convenient things. Then we've got our system services, which will have most of your basic types, and then your Windows and messaging and GDI graphics as well. So those familiar with Windows programming will be familiar with GDI and how to make a window like this. You've got your message pump and your Windows proc here. That's really simple. We just take the destroy message, we take the paint message, and we paint just a blank screen. And one thing I like about Zig is when I'm initializing this window class struct, I can have the compiler make sure I initialize everything. So that's one nice feature that Zig gives us. So let's go ahead and make sure that this runs as well. It's going to open up on my second monitor here, but there's Hello World window. Let's look at a COM example. So the open file dialog. So this is one of those useful features in Windows, but it's behind a COM interface. But that's okay in Zig now. We're gonna include system.com and then we're using COM, baby. open file dialog. We're gonna call co-create instance. We're gonna give it the ID of open file dialog, which is in the metadata. And then we're going to call a function on it. And this one was a little interesting because COM actually lets you define the same function multiple times with different types. And Zig can't do that. Zig doesn't have overloading. So the solution I have for now is every function is prefixed with the interface that it comes from. I believe each function is unique to the interface, but since it's hierarchical, you can include functions from your base type as well, and they could have name conflicts. So as long as we namespace it with the interface that we're calling, I think it works. I haven't fully confirmed that. But in this example, we call this show function, which will show a dialog to the user, and then we'll call get result. And again, this is not how you would normally write this function. This is just an example ported from C++, and the goal is to make it look as similar to the C++ example. I would not write it this way in Zig. And you'd also probably want to write some wrappers around these that turn these things into Zig errors, and then you can use your tries, you can get your defers to work and everything. So let's see this one in action as well. It's called open file dialog, and this is gonna open a little file dialog, and then when I select the file, it's gonna show me a little pop-up with the file name I selected. So there's the file name. So great, we can call com types. This is so cool. I was super elated when I got that to working. You have no idea. And last but not least, this one's puts together even more. It's using the Direct 2D API, which also uses COM interfaces. The example I found has a library, so I was able to. It actually uses C++ inheritance, and I was actually able to emulate that pretty easily in Zig as well by using this base type. And I don't remember if I needed to use field parent port. I guess I didn't in this case. But yes, we can call Direct 2D in Windows. So now you can write all your Windows games in Zig, no problem. And let's just see that one running. Direct 2D D2D circle, and this should just open a window and give us a circle. So great. So all these examples are great, but you may be asking, well, how do I use this in my project? How do I get these sweet APIs? Okay, well, let's look at I have a real world example here. I wrote a tool called Windows Remote Control, and it lets you share your keyboard and mouse with another computer. So, and the idea is you'd have the other computer sitting beside yours with a monitor, and then you could move your mouse across the screen, and it would jump over to the other one, and then you can start typing on that computer. Let's go ahead and clone that one. And actually, let's delete all this stuff that we just generated, because I want to show you that you don't need to have a local copy of all this to use it. Okay, continue. Well, it's not letting me delete it, but I'll delete all the contents. Okay, there's nothing left in that folder. Let's go ahead and clone this project. Git clone Windows Remote Control. Okay. So same pattern as before. Let's run a Zig build. And very, very similar error message if you've been following along. My ad hoc package manager infects all my projects. So let's go ahead and clone this repository that we're missing. And it's telling us we're cloning the Zig Win32 project. So this is the final result that we're cloning into here. That gives us access to the full API. And for those curious of how that works, it's pretty simple. I have this Git repo type. It's about 40 lines of code. And with it, I'm able to add dependencies in my build.zig file. So I can tell it, oh, here's the URL, here's the branch I want. And then you can give it a SHA, which in this case is important because if the Zig Win32 gets updated, which it does often, then you don't want to use the new version, which probably won't work with your code. So this guarantees that we're always going to get the exact same thing. And then I've got this convenient function which resolves this repo and returns a file name, a file path. So all you need to do is take this file path and add it to your executable as a package, and then you're off to the races. So okay, so we cloned our repository. Let's run Zig build again. And this time, now surprisingly, one thing you'll notice is it didn't take that long. Zig's lazy instantiation is to thank for that. Even though we've got hundreds, I think it's about 115 megabytes is the Zig 132 project of Zig code. It still builds pretty fast because it only needs to analyze the stuff that we're using. So let's go ahead and run this project. It doesn't, you won't see much, but you can at least see something here. Oh, that's right. I need to give it a JSON file first. Let's do that. WRC client.json remote host 7001. Okay, go ahead and run that. And so it shows you this window. It says it's not connected to anything. Shows you where your mouse is. And then if I had connected to something and I moved my mouse over to the side, it would jump over and then control the other one. So there's the demos. That's how you would use it in your own project. Simply, you could use my method, or you know, there's other methods as well. You can use Git submodules. You can use a package manager. That might become relevant in a few minutes with the next talk. And then you add a package, and then you're good to go. And this is what the code looks like. So if we take a look at WRC client, so I import all the stuff I need here. There was some stuff that was missing. So like, for example, this low word and high word are actually macros. So metadata doesn't have macros at this point in time. They're also missing invalid socket for some reason. So that's probably going to need a GitHub issue in the metadata project. And I found that the metadata project, the developers are pretty good. I've probably opened a dozen issues or so, and most of them are all closed at this point. So they're pretty good about fixing issues like that, which is nice. So final thoughts. To close off, I just wanted to mention a couple features that I'm considering adding. One of them is better interop with the standard library. So what I do currently is I hard code some of the types so that instead of generating them myself, they actually reference the ones in the standard library. So this way you can take a socket, for example, that's generated from Zig132 function and use it with the convenient functions in Zig standard library. So the other idea I have is, and I'm not sure how this will look exactly yet, but my thought is I'll probably work on generating code meant to be in the standard library. And so I'll have a list of functions and constants that will go in the standard library, and then my tool will separate those out into a special module meant to be deployed there. And then everything will in the main library will reference those from the standard library. So then all the types that are shared will be the same, and Zig's type system will be happy. Oh, there's the graphic I forgot to show, explaining that. So, and then one more idea I had was potentially auto-generating wrappers. So this would do things like translate slices and Zig errors into the corresponding Win32 mechanism. And Win32 doesn't have information about error codes yet that apply to each function, but they might add them later, and that could be a feature that we could request. And we could also maintain a list of that ourselves in the meantime, or add them to the JSON file ourselves. So that's the project. Thanks for watching. You can get a hold of me through email, or you can find me on IRC or Discord usually. And that's all I have.
Thank you very much, Johnny. That was a great talk. Okay, I enhanced your webcam, and I think it's time for a Q&A. So if anybody has questions, please write them in chat. Maybe at me to make sure I don't miss them. In the meantime, I think I have to ask you the basic question that I ask everybody. So, how did you find out about Zig, and how long ago was that?
I actually answered this question on the Zig forums a few weeks ago, and I remember that I could not remember exactly where I heard about Zig, but I'm pretty sure it was probably through Googling some language thing and then just finding Zig through Google. Um, and then I looked at it, and I look at a lot of languages, but I remember looking at Zig and being really intrigued by the website and its design philosophy. And at that point, I joined the IRC and talked with Andrew, and I started contributing right away. And then I kind of took a hiatus from Zig, but then I came back a few years later, and when it was more mature, and I'm happy to use it now with where it's at. So
I see. Great. Uh, wow, that was a very interesting story that you told. So, did you tell anybody? Sorry, step back. I think you mentioned that the your Win32 bindings project is linked on the README, right, of the official repository by Microsoft.
the Win32 binding project, because there's 5 projects. There's the
Yeah, sorry.
regenerate.
I mean the Z bindings
Okay, and is it linked in the README of what?
of the Windows the Microsoft projection repository.
Yes.
Yeah.
Yes. So because I keep bugging them with issues, somebody asked me, "Hey, are you working on a projection?" I said,
Uh-huh.
"Yeah, it's Zig, and here it is." And he's, "Oh, great, we'll add you to the list." And so
Nice. So who else is on that list?
there's only a few so far. I can pull it up. It's like 5 or
Yeah.
6. Microsoft Win32 metadata. So here's the project on GitHub, and I think it's in Docs projections. So you can see here's the C# one. This is the one I kind of stole and used for my project to generate JSON. But they've also got C++, which is interesting, right? They have the normal C++ headers, and then you can use the ones from the projections from this
Why?
projection as well. Well, it's interesting. Like I think they kind of explain it somewhere in here, but it gives you better type safety and name spacing, and you can actually write some like nicer C++ code using the projection. In theory, like it's still pretty young project. Yeah, and somebody did it in D as well, and there's Dart, and then here's Zig here. So
I see.
we're official.
Yeah. Awesome. Okay, let's see. So people were commenting earlier. Let me see. Comments. Okay, so first, the first question that you received while the talk was, while you were speaking, was from Matt Knight, who said, "Can we stop the talk for a moment to appreciate the beard?"
Well, thank you very much. Like, it didn't used to be this long until COVID happened, and I've kind of just been letting it grow out, and some people seem to like it, so I guess I'm letting it stay for a while.
Okay, let's see other things. With regards to the linking error that you found, Andrew was pointing out that he only sees these parse .def files in MinGW64 for the ARM32 target. Interesting.
Okay, so I didn't show you, but the metadata recently added the ability to identify certain APIs as target specific, and it has different versions per target as well. So the way that I do that in Zig is I have a variable that there's only 3 targets: the x86, x64, and ARM target. So I just have a switch there if they're different, and it just does the using namespace struct trick. So probably what happened was there's probably an API that isn't in x86 64 that the metadata said was in it when it's only in ARM. So that's probably what happens. It's probably a bug. You'll probably find out which symbol it is and file a bug for that.
Mm-hmm. Okay, that's cool. So I have one final question. So you showed that there's a lot of namespaces there, right? Like a lot of APIs. And how well known are those APIs? Like, do people usually know about all of them, or only like a strict subset?
I think it really depends on the industry you're in. So if you're writing games, you're going to be very familiar with DirectX or OpenGL and the audio APIs. Like for example, if you follow Casey Handmade Hero, he's going to be very familiar with that section of APIs. But he's probably not going to know anything about the machine learning. Probably hasn't messed with the networking protocols or Windows is just so big and there's so many APIs available that I don't think people realize. And that's why this problem was so hard. When I initially set out, I actually didn't know how big it was. And I thought, naively, oh, this won't take that long. And then I realized, oh, okay, it's really big. So
Mm-hmm.
I would say no, like most people don't know probably how big it is and all the sorts of things you can do with it. But yeah.
Well, now they have an opportunity to know. Okay, so that was awesome. Marler, Johnny, is there anything that you want to say before we move to the break and then the second half of the show?
No, thanks for having me. This has been great. Maybe I'll do more talks in the future. I do a lot of projects, so yeah, maybe check it out again, and maybe I'll come back.
Awesome. I'm actually looking forward to it. That was a great presentation. So thank you very much
Thank you.
again. And I think it's time for me to move to the break. So everyone, 10-minute break. And then we are going to the second talk. So feel free to tap out for 10 minutes only. Then we're coming back. Um, Hello, it's 40 seconds remaining. We are going to start right on time, so uh, please tune out from the Fortnite stream that I know you opened while we were waiting. As most people know in the Z community, as most people in the Z community know by now, Megan and Matt have been trying their hand at writing their own package managers for Zig. In the past, we had Matt talk about his implementation, while today we have Megan showcase hers. I think the best way of introducing Megan is by saying that she started programming for one of the noblest possible reasons, which is to write Minecraft modes. The talk is titled Thoughts on Robust Package Management with Zigmod and Aquila. Megan, the stream is yours.
Thank you, Lars. Yeah, so historically, being a developer and a maintainer have been kind of two different roles because they're both like very difficult. And so I made Zigmod and Aquila as kind of prototypes to see, to try out some experimentation on what we can do to bridge that gap. So just as a quick disclaimer, I wanted to say that this is an experiment. Zig plans on building a package manager directly into the Zig build system. So the main takeaway here is kind of the underlying philosophy, but the software is available right now. I also have a registry app that I'm going to be showcasing that may exist, but we'll see. Once Zig adds official package management support, it will be updated to work with that. At the moment, it's very tied to Zigmod, the registry being Aquila. Yeah, so for the talk, I'm going to go over the package manager, which for my case is Zigmod, and then I have a registry called Aquila. So package managers. So I wanted to go over some things that we should get right because people have a lot of gripes with other package managers. So before we do that, let's go over what are our goals. So for part of the philosophy that I approached was be declarative. So the actual manifest format that you define a package with is entirely declarative. It's not Zig code because I didn't want like dependencies to run code while they're on the machine or like on the developer's machine, like while you're fetching dependencies and stuff, because you're on the developer's machine. That's a very sensitive piece of real estate, and you kind of don't really want to trust dependencies until they actually make it into the end program. Also, another big thing was be specific. So looking at a lot of other package kind of manifest formats, this is along the same lines. They're very tied to like a central registry, or actually not even, they usually just have a name and like, I want this package, I want this package, and I want this package. There's like some complex algorithm in the background that not everybody knows on like on where those names are associated to like files on a server. So another big thing here was be specific. So you're not like, oh, is it going to this registry? Is it going to a private registry? Yeah. Also avoid the network as much as possible. This is like for when you're fetching dependencies because it's slow and unreliable. So when your dependency definitions are done in a mutable way, you can kind of only fetch what you absolutely need, which makes the fetching process a lot faster. And then I said for examples here, using like specific versions, git tags, hashes for tarballs, and more. Another big thing I tried to do was keeping debugging easy as possible. So when you do fetch dependencies, it saves them in a folder relative or based on the path that they're stored. So that way, if say you have a stack trace and you get an error about something, if it went through a dependency or it's in the dependency itself, you know exactly right away where it's coming from. And then this was for Zigmod, but integrate with the Zig build system well. So what Zigmod does is it generates a deps.zig that you import into your build.zig, and then there's some helper functions and there's some other intricate things you can do with it, and then it makes Zig build have the same experience for everyone, regardless on whether they're doing it manually or they're using Zigmod. And then be decentralized was a big thing that Andrew and team also said that they wanted, and Zigmod kind of follows that. So it supports Git, Mercurial, HTTP tarballs. There's going to be support for like sub packages. You can get data from any host or URL. It's not tied to like all three of those remote types are not tied to like a specific. There's no single source of truth. And the base program, although there is integration for the registry, the base like fetching program has no concept of what a registry is. It only sees tarballs as like from a web server. And then so for some specific examples, this is how Zigmod allows you to use these today. So there's Zigmod init after you initialize your project. It will generate a zig.mod file, which is going to be your manifest format, based on some properties in your project. So there's this ID. Actually, we'll get there. So the zig.mod manifest format. So there's an ID. This is kind of a new thing based on some comments I saw in the package manager issue on GitHub. So this is used to uniquely identify your package coming from any sources. So say you initially start your project on GitHub, but then you end up moving it over to GitLab, or you move it, even within GitHub, you move it into an organization or you change the name. So this ID values allows Zigmod and the package manager to recognize that they represent the same package. So if you have, say, one dependency that imports it under this name, and then you have another dependency that links it from, GitLab, it can recognize that they're actually the same package, and then use that when it's to prevent name conflicts and stuff like that. There's the name, which is what you put into the @import string. There's main. This is actually optional. So if you define it, it becomes the Zig entry point for your package. But Zigmod also has support for like defining C libraries or defining like having C code in your package. So if your package is just providing a bunch of C code to the parent project, you don't actually have to define main. And then there's also dependencies and dev dependencies. This is a little different from how like package.json will work with Node. So dependencies are made available to the library. So made available to import main. And then so dev dependencies are for if you're building like an actual like end user application. And then so that makes them available to root. And then main will become also available to root. And then there's a lot more fields, as I mentioned, with like the C code and some other stuff you can do. Zigmod fetch, this is like the main thing you'll be doing when interfacing with Zigmod. It'll read your zig.mod manifest, download all of your dependencies recursively, and then put them into deps.zig and a local folder. There's deps.zig, which is generated by, that's wrong. So this is generated by Zigmod fetch, and then it's used in build.zig. There's a nice handy helper function. So you can import deps and then add alt2, and then just put in an exe or a lib, and then you're good to go. It'll add like all of the C code that was imported, all of the packages, and it'll do it all of it for you. And then there's also a reference. So those are like the main kind of core loop, I guess, of Zigmod. And then there's also some helper functions that I wanted to go over really quickly. I showed this off in a previous Showtime. There's Zigmod license. So one of the optional fields in zig.mod is a license field. And then so this, because Zigmod has like a view on your entire dependency tree, it can list every single dependency and group them by license. Another thing that's shown here is if the licenses being used in a project are like a standard like OSI identifier code, SPDX identifier code, it'll also insert a link to the license. So you can read the text and see if it's compatible with the different things that you're using and whatnot. There's Zigmod sum, so you can, this can be incorporated later. This isn't used directly at the moment, but you can also like run this file multiple times and then track changes. And it'll show you the Blake3 hash of all of your dependencies. There's Zigmod ZPM. So there's native integration with zig.pm, which is a registry bookmark website for awesome Zig projects by Master Q32, also known as XQ. And then there's some subcommands for searching, adding projects, and then also seeing the different tags. And then there's Zigmod AQ, which is the native integration with Aquila, which is the registry that I'm going to show off in a second. And then there's like add and update. So now we have registries. So with registries, versioning is hard. No one does semantic versioning right, or like almost no one. It complicates a lot, and a lot people mess it up all the time. Being a maintainer is hard. Keeping dependencies up to date is very tiresome, and making sure updates. Part of why it's tiresome is because like making sure updates don't break your code is a lot of work. And then being a developer is hard. We have hard jobs. Making sure things are secure is hard. Making sure like dependencies that you want to add aren't malicious is hard. Tracking changes and stability in the dependencies that you add is hard. So Aquila, the registry that I am working on, has a couple proposed solutions for a few of these problems. And then it's available right now at this website. And then, this is very new. It's a very recent project of mine. So there's a lot of planned features that I have not quite implemented yet, but it is usable. There's just much more to come. So for versioning, Aquila doesn't use semantic. It gets rid of the third version and just has major and revision. Major is for breaking changes, and then revision is for non-breaking changes. If you want to have like a full rewrite, best case scenario, that should honestly go in like a whole new project. And then part of that confusion with versioning is like, what is a breaking or non-breaking change? So if you are only expanding your API surface or have non-breaking bug fixes, that's a minor version. If you add or if you remove public functions or constants, that's a big breaking change. Or this pertains a lot to Zig. If the error surface of one of your functions changes, that's also a breaking change. So being a maintainer is hard. Part of why is because checking for version updates is kind of this polling process. Like you constantly have to wonder like, do my dependencies have updates? Do my dependencies have updates? Instead of, I went with this interrupt-based one. So I thought a really kind of simple-ish fix to that is you can just kind of get notifications on the website when people hit publish on a new version. And then down the line, I also want to have like a CI feature. So if your project, whether it's a library or a like end application, defines tests. It can run them for you, and then in like a dependent bot kind of style, be like, hey, here's a new version. We already ran your tests. We know it works. Or on the opposite side, we can be like, hey, we updated with this new version and something broke. So then, you can go back and figure out, well, did dependency break something? And or did I do something? Instead of like constantly having to wonder like, are updates out there? And then yeah, so the site can just give you notifications for, oh, so this part was actually about the security point. So another thing I thought was like, oh, so if there's one maintainer on a project and then a new version gets published by a new maintainer that, you didn't get told about, it can actually tell you like, hey, this new version came out and it's by someone, this is the first version that they've approved on this project. Maybe you should, take an extra care to look at the changes. And then this one is actually already implemented. So when you're looking at the version page or versions page for a project or a library, it can actually show you the code diff between the different versions. So you know exactly, the commits that were made and the code that changed. And then obviously, you can see how many like download statistics or like how often the package is updated because it'll show you like when the published date. And Aquila is also self-hostable, and the plan is for it to be federated and the CI features to work across like all instances. So I host the Aquila.red site, but then say you go to host your own, if you depend on a package on your own registry from a package that's say on Aquila.red, Aquila.red should send you the it should still work, and the update notifications are still going to work across instances. Yeah, so just some quick closing thoughts. Zig's kind of tagline is that, it's a general purpose programming language and tool chain for maintaining robust, optimal, and reusable software. Everything in that sentence except for general purpose programming language applies to how we solve package management. And another thing was another thing that, I kind of took with the philosophy of this is that the most efficient, secure way should be the simplest way. So, making your job easier goes a long way. And then yeah, there's still a lot of improvement, but they're good for now. Yeah, so these are the GitHub projects and the websites, and thanks for listening to my talk.
Thank you very much, Megan. Okay, let's switch to the Q&A view. Okay, so first of all, if anybody has questions, as usual, feel free to write them down. In the meantime, standard question for you two. So how did you discover Zig and how long ago was that?
So I discovered Zig right around towards the end of the 0.6 timeline. So it was like a month or two before 0.7 came out. I had always been interested in this kind of like C alternative and language design in general. And then YouTube eventually recommended me one of Andrew's talks, The Road to Zig 1.0. And then I watched that and I was like, oh, this looks neat. And the more I watched it, I was just sold like right then and there. And then I was like, I joined the Discord, I found the GitHub, and it's been wonderful ever since.
Awesome. Okay, so
I can also show a quick demo as well
Yeah.
if people are still bringing in questions.
Yep, bring it up if you want.
Cool. So for first things first, an example for Zigmod, so this is a packet. This is a project I have called Discord Archiver, which you can use to archive a Discord server. And here we have a Zigmod file. As you can see, it has the ID. This is auto-generated for you. And then you have the name. You can also have like a license and a description. Those are some of the other optional fields. And then these are other dependencies that I added. So these are some of my projects. This is a wonderful HTTP library by TrueMedian, also known as Nameless. And then these are Git projects. So this is with everything deleted. This is almost exactly like what you'll get from just a Git clone. So we have Zigmod fetch. So this will save all of our dependencies automatically right in this Zigmod folder, and then also generate the deps.zig file that we need. Excuse me. And then we have zig build. Very nice, super quick. And then I have this little test script that I wrote. Then it's off to the races. Cool. So yeah, Zigmod. Nice and easy. And then this is the website so far. So you'll have like a list of, these are new packages. So as a quick example, we have, this one has some versions. So you can see, so for a package, you have the owner, you have the like host project on GitHub. This particular one is a list of all the TLDs for domains. You can see the different versions, when they were published, the source like at that particular commit where the file is being stored. And then also this is that diff compare. So you can see between 0.2 and 0.1, nationwide, the .nationwide and .on your side top level domain names were removed. And then if you go to click on one, you can see a file list for like all of the files in that package. Any dependencies that they may or may not have. This one doesn't have any because it's just a static string array. And then also how big it is and the hash.
Mm-hmm. Have you been enjoying writing the Aquila website?
Yeah, that's been fun.
Well, I'm asking because, like, I know that you told me that you do have some web programming experience, but like, there's a lot of people around here that like, kind of, they don't super enjoy it. Well, I agree with you. I had a lot of fun writing the, for example, the Zig website redesign. So yeah, okay, cool to know. So there's a question by Andrew. What is one especially tricky thing that you run into when working on Zigmod, and what would you want to? Okay. So it's a long question. So let's start with what is one especially tricky thing that you run into when working on Zigmod?
What's an especially tricky thing I ran into while working on Zigmod?
Yeah.
Oh, I think.
Okay, now I decoded the second half of the question. Sorry, Andrew, that's on me. So, and the second half of the question is, well, and if you wanted to warn somebody else about this tricky thing, maybe somebody else that is thinking of writing a upstream package manager, I don't know, somebody like Andrew, for example, what would you want to warn them of?
There's one feature that I saw there was rumors about getting deleted that kind of, I guess, breaks a lot of things, or I didn't know how it would get fixed. So there was one issue that I saw where they wanted to make it so at import only accepts the string literals. The reason I thought that was a little problematic is because so you can have like in deps.zig, there's packages. Oh, okay. So there's this packages that are referenced by name. And then these correlate to their packages in here. So if, say, one of the packages in here was, something about, say I was writing a C program and I had a Zig project that could look at the exe and then auto-generate, like, say, a header file. I think Zig can do that automatically, but like just for the sake of example, if it was like a dependency. If you wanted to do that, you could do, say, like equals import steps packages, JSON.path. But there was a proposal to have that removed. The kind of, it leads to the question of like, how do you get dependencies for build.zig when it's the method by which things get dependencies through like add package and stuff. That was one. D was a big thing. Because and then also like it wasn't necessarily technically difficult, but like the fact that it's such a social thing makes it difficult. I guess I would say. And getting people gearing people in the right direction makes it a lot easier.
Okay, another question. This one is from Power of Zero. What are the provisions for packaging non-trivial C projects for Zigmod packages?
So I can show you how you add C code. If they could elaborate a little bit on what they mean by non-trivial.
Well, I'm guessing like a project where maybe there are some constants that you have to define that has some dependency on system libraries.
Okay. Yeah, so for just C code, here's an example of a wrapper package I made for Z Standard, which is a project by Facebook. So some of the other optional properties are the C includers attribute, and then that's just a list. There's C source files, which is just a list. And then it's not listed here.
One sec, because I think we lost a frame from the video streaming in the worst possible moment. Give me half a second. Can I refresh this page? Is it going to work? Can I click refresh? No. Okay. Okay, sorry. Please continue.
No worries. Plug in my laptop real quick. Yeah, so we have the C includers attribute, which is just a list here. Whatever your project happens to need. And then we also have C source files, which is just a list. And then it's not listed here, but there's also a C source flags attribute. For system libraries, that's actually its own unique like dependency type. So you can go system lib and then say GL, and that's how you'd make a game.
Okay, I think that's a good answer. If Power Zero has a follow-up question, then I'm guessing we'll see it soon. So let's see, people are chatting about your comments on how to do import stuff. Matt is pointing out that SDL2 is a major pain in the ass, apparently. Okay, so I'm guessing the package manager, as we said, we're gonna end up with a package manager, like an official one in the compiler itself. But we don't have plans to have a official package index, right? We want to have the community come up with their own stuff. So you mentioned some projects that you want to implement in the future, some of which are like CI stuff. Probably it would take, I'm imagining, a while before you get there. Is there any other like super long-term plan that you would like to have one day? Like I'm not asking you to promise stuff that that you will have to follow through, but like if you had infinite time, what is a super cool thing that you think you would want to have in the future?
There's a lot. I mean, that came out wrong. I'm not sure.
You're not sure. It's okay. It's okay. So you said that you wanted to be federated and have also a federated notification system. I think nothing like this exists for any other package index that I know of.
Yeah, there's a lot of centralization in projects in general, because there's, I think that there would be some sort of centralization kind of naturally, because people would gravitate towards an instance that has the funds and resources to host an instance, say for the community. And that might be, a couple different people, whether that be like one website or, two or three. But I also like wanted to have the option to, like, if say people wanted to host a personal one for just their projects on their own infrastructure, and not make it so that that's like a miserable experience, and still like allow them to incorporate with the rest of the ecosystem. Going back, one currently unsolved problem is, say you have SQL 3 as like a system library, and then you have, so say you have these two projects. This one links against a system library, and this one builds from source. There's currently no way to like let the user pick which one they want, and kind of have like an optional, like, oh, do you want to link the system library, or do you want to build from source? So that would be like a good problem to solve. One thing I think Matt brought up that's might help with a project like SDL2, is, say you have, Git something. If say, this is Marler's Windows project, but you're building like a Windows application, you can say only OS Windows. And then so when someone is running, say, Zigmod fetch, this will only add the dependency into the tree if the host target is Windows. You can also say like except OS, and then this will run on everything except Windows.
Yeah, makes sense. And I think that you coincidentally just answered another question that came up in the meantime. Awesome. Yeah, okay, that's cool. I'm actually curious to see a package index that is decentralized, and I think there's a lot of cool things. Your idea of having the notification system propagate these notifications across different instances caught me by surprise. I wasn't thinking of that, and yeah, it's a cool thing. I guess the thing is, some of the current package indexes do allow you to self-host, but the idea is that you're only self-hosting to have like a private index, private repository, like in your company, your organization, where you don't want to have anything to do with the rest of the world. So yeah, that's a curious direction that I'm sure we'll have. It's an interesting design space to explore, I'm guessing. Okay, I think we are good with the questions and everything else. Is there anything else that you want to say before we move to the end of the show?
Thanks for having me on and doing Showtime. You're a great asset to the community and you do a great job.
Thank you very much. Well, likewise, I think a lot of people have been enjoying Zigmod and interacting with you in the communities. So with that, and also 3 talks, Showtime t-shirt, so don't forget.
I'll have to keep that in mind. I'll definitely be back. This was a lot of fun.
Awesome. Yeah. By the way, I don't remember, did you share your social media stuff at the end?
Yeah, I have these down the bottom. I'm on GitHub, Twitter, and then I also occasionally stream.
Cool. Right. I have a small preview window, so I couldn't make them out. Okay, perfect. With this, then, I think we can finally get to the end of the show. Well, thank you everyone for being here. I hope this was fun. I know, oh no, it's 1 hour, 47 minutes in total. I think everybody got used by 5-hour-long Showtime episodes by now. I'm sorry to disappoint you all. We'll get back there. Maybe not. I don't know. I don't want to make promises. So in any case, I think that's the end. So see you next time. And also, the 0.8 release is coming up, and there's going to be a release party soon.
This is how we